And welcome back to GCSAA TV live from San Antonio, presented in partnership with Lebanon Turf. My name is Chris Gray, and I will be your host for this segment. We're going to be talking about current industry research trends. So I'm joined on stage by Dr. Clark Throssell, one of our industry's great researchers. Clark, thanks for taking some time to join me on stage today.
Thanks, Chris. Happy to be here, and I always like to talk about turfgrass research.
Well, you're in luck, because that's what I was hoping you would want to today.
Good deal.
And so I guess some of the questions I have, I mean, I was a superintendent for 15 years, and I know how important research was and how it's highlighted very prominently in a lot of the magazines that we read, our industry magazines, and it's used by not only the manufacturers, it's really become very important for superintendents to have access to that information to help them make decisions based upon products on that one. But there's a lot of stuff that I'm not quite sure about how it actually all kind of works together. And so I was hoping we might be able to lead some insights into this. I mean, would you say that, I mean, how many different types of research are there that's being done today?
Yeah, it runs the gamut in turf. You see all different types of research, things that would impact the plant, things that would impact the soil, water, energy, and the environment, and then of course all the products that go into turf management. So it really is covers that whole spectrum.
Okay, that certainly makes sense. I mean, and I know that obviously there's a lot of research that's done by companies that they want more efficacy data on what the products are, but out of all the research that gets done, I know not all of it gets published. Not all of it winds up to be available for superintendents to actually be able to read. How does that process work? I mean, is there, who decides that whether something gets published or whether it doesn't?
Sure, it's a combination. Obviously, much industry research is proprietary in nature, and so the company that does the research would use it for their internal use only, but obviously there's some proprietary value to that, and so they're reluctant to share that and to protect their own economic interests, and I think that makes sense to everybody on the industry side. A great deal of research on efficacy of a product does get out in various forms to the superintendent, because that helps superintendents make wise decisions on use of the product. And then university research, and most university researchers, that is their goal, is to publish the research. That's part of their responsibilities. Okay. That's what's expected of them at their respective universities. And so the university scientists do a good job of publishing their research.
Now, do these university researchers, the scientists, is the research initiated by them? Do they decide what to do? Is it usually, do they try to find someone to help sponsor that? Kind of, who initiates the beginning of each of the studies?
Yeah, Chris, a little bit of all of the above of what you've mentioned. A lot of the research that gets done comes from the superintendents themselves, by communicating with the university scientists. Hey, this is the problem I'm seeing in the field. We don't have a real good solution to it. And so a lot of the research that happens comes from the end user, and that's the superintendent. Okay. And so it's a real key part of the whole process, is for superintendents to have an open channel of communication with university scientists and industry scientists to say, hey, these are my problems, we're struggling to find good solutions to it, and so can you help us out? And so from that, then the university scientists will take that problem and then build a research an experiment or several experiments around it to try to attempt to solve that problem. And while they're doing that, then that's when they'll seek out sponsors to help fund the research. And the funding could come from a GCSAA chapter, it could come from a funding organization like the USGA, or it could come from industry who might have products that would help solve that particular problem, or in a lot of cases it's some combination of all the above.
So it really depends on who's actually, the availability of when the report gets finished, once the research is done, whoever really helps sponsor the bill, whether it's private research or public research, that kind of determines whether or not these are going to be published and be available for like superintendents to read?
Yeah, a little bit, but most of the research that gets done, whether it's funded, certainly if it's funded by a chapter or the USGA, that's going to get published. Sure. And a great deal of industry research gets published because those companies involved want superintendents to know that, hey, this product works, and it's effective, and everybody gains in that, because then superintendents are solving a problem, and then of course the company's supplying the product that solves a problem. So in my mind, everybody wins, and I think and all in all, it's a great system.
One thing that's always struck me is that what I see, like, oh, we got new research that comes out, and all of a sudden it's dated like 2 years ago. Well, it seems like the timing that to get the research done, to perform it, and then to do the actual analysis, and by the time you write up a report, kind of walk me through how long does it take a typical study from like initiation till you could read about it somewhere? How long does that process normally take?
Sure, I would guess, Chris, it would probably take about 4 years to 5 years to see
Wow.
it, in print. And I'll walk you through a little bit of a timeline to help explain that. It would take about 2 years to 3 years to do the project in the field. And a university scientist or industry scientist, you want to repeat the project because
Okay.
one year, what you see 1 year can be sometimes misleading. And so most university scientists, industry scientists want to do that project at least 2 field seasons.
Replications.
Yeah,
Okay.
exactly. And if not, even a third would be ideal. And so that way you feel more comfortable with the end results and more comfortable with your recommendations.
Sure.
And so let's say it takes 2 field seasons to collect all the data that you need. Well, then the next step is for the scientist or the graduate student that's working on the project, then, as you mentioned,
Yeah.
to analyze the data, and then to write up the results in a format, and typically the first place it's published, results are published is in a refereed journal article, a peer-reviewed scientific
Oh, okay,
publication.
yeah.
And so the student that's writing it up, typically with help from their major professor, input from their major professor, they write it up, and then so submit it to the journal, and then it has to go through a peer review process, and that takes 6 months, something like
Wow.
that. And so usually 2, if not 3 people have to, with qualifications, knowledge of that subject matter area, review the article, would decide is it worthy of publication, and then make suggestions on improvements. It goes back to the graduate student, then the graduate student makes those, considers those recommendations, makes those improvements, and then it goes to publication. And so that can take 6 to 9 months by
Yeah.
itself.
Holy, I can see graduate students have a lot on their hands. So.
Yes, they do. Yes, they do. And that, by all means, the publication process is generally the most challenging.
Sure.
Doing the research in the field is fun and exciting, but publishing it, writing it, and publish it, that's a grind for most people. And so then it gets, first of all, then it's published in a scientific journal, and then after that, once it's published in a scientific journal, then it would be published in a trade journal. And so then there's a little bit of a lag time for it.
That's quite the long road.
It is,
I mean,
it is, and so a lot of times the results will get out to superintendents before that through presentations at turf conferences,
Okay, yeah.
or showing it, demonstrating it at a field day, at a university field day. So the
right.
results in at least maybe short form get out in that manner first, and so quite helpful. But then the formal process of publishing in a
Wow.
referee journal does take time, and then after that, then to get it to a trade magazine.
So what's
industry
the best
trade
place
magazine.
for a superintendent if they want to see what the latest research is? Is it the trade publications, or is it more like what you were talking about there at conferences or at field days? Well, what's the best ways?
Yeah, a little bit of all of the
A
above.
little bit, okay.
But I think the industry trade magazines do a great job of getting information out and in a practical form that superintendents can digest. Reading a scientific journal article, it's hard work, even for a scientist such as myself. It's hard work, and they're written for scientists, not the end user, so it's better to read the industry trade magazine version of it, so that's a great outlet.
Okay.
Conferences, field days are other great outlets to hear about it, and then I find following your favorite university turf program or your favorite university turf scientist, and going to their website and reading what they're doing, because you can see a lot of their work in as progress reports along the way, or in final reports, and so that helps. So if you're struggling with, say, some sort of disease problem, well, who are the 2 or 3 turf pathologists that are really focused on that disease problem?
Sure.
Well, I would follow them, what they're doing electronically, and some have Facebook pages.
It's a great idea.
Yeah, some different levels of activity, but go to that university's turf webpage, and you can get a lot of information about
No, I think that
the
makes a lot of
current
sense.
projects. Yeah,
Yeah, I don't think I could like name my favorite turf researcher, but I can see why it would be very helpful to do so.
yeah.
I'm sure.
Understand.
I'm sure, like everything else, there's trends about different things. There are hot topics going on in the industry. I know one of the topics that actually was at one of your presentations was the use of drones, or as you call them, unmanned aircraft
Right,
systems.
right, I want to be correct. Yep.
Yeah, no, and you'd be accurate. I'm sure there's a reason why you call them that. Tell me about what's going on with that.
Yeah, that's an interesting area of research. The technology is fascinating. Certainly the drones are widely available at a relatively affordable cost. And I think, I've never tried to fly one, but people tell me with a little bit of practice, you can be proficient at it without much time invested. So there's that, and then the sensors are available at, again, a reasonable price that are very good. You can do something simple as just a digital camera mounted on a drone to get a bird's eye view of your property, of your golf course.
Okay.
I think that very, very helpful spatial relations, how things look, and I think very helpful how your property sits like in a watershed compared to your neighbors, what your neighbors, how that might impact your golf course. So I think that's very good. And then there's also sensors that measure spectral reflectance or light that's reflected back off the turf to the sensing device. And the way all plants, and that includes turf, reflect light is an indicator of their health, overall health.
Okay, so you get a bird's eye view of the health of the turf from however.
You bet. And so I think one of those tools that is coming our way, I'm not sure that how refined it is yet, and I think that's where university scientists and others are working very hard. You can collect a great deal of data, but interpreting the data, what does it mean and how can it help a superintendent is still working on that. And the real challenge is, Chris, you want to sense, say I'll use something very simple as a dry spot. Well, that turf is dry. Well, if after it doesn't get water for 2 or 3 days, well, you and I can see it and know that, hey, this turf's dry, we need to take some steps to correct that or prevent it. What really sensing it does, you want to know it 2 days in advance of when we can see it with our own eyes. And so I think that's the advantage of some of this remote sensing, but yet there's a lot of data, and then you need to know what you do with it, and you need to heads up, you need the advance warning. So if that sprinkler head has broken, stopped turning, I'd like to know it today, not 3 days from now when I can see it. And that's some of the challenge that's out there.
So it just gives you a new, unique perspective that you've not previously had. The use of this technology with the sensors allows you to do that.
It does, yep,
So
that's
they're
right.
working on trying to find a way to actually make that more accessible for the superintendent to be able to make it another useful tool in the toolbox.
Right.
That makes sense.
Yep, think of it as an early warning device.
Sure.
And so you can try to get ahead of the problem as much as you possibly can.
Okay, that's good. What about turf breeding? I know that's always a big topic. We're always trying to come up with better strains, but what's new with that?
Yeah, it's amazing to me the progress that's been made in plant improvement. That's what plant breeding is. You're improving the plant itself. And you look back when my career started, Pencross was the standard cultivar for putting greens. Marvelous grass. I think people think it's the most widely used, at least on golf courses, the most widely used variety ever. But now there's so many things. We've moved several generations past that, and you see now today these really ultra dense creeping bent grasses that will tolerate the low mowing heights that golfers need, or that superintendents need to meet the demands of golfers. And so it's phenomenal. So if you look at a plot of Pencross versus what's on the market today, it is staggering the difference. And that's plant breeding. So, and plant breeding is one of those things that's incremental to me. Every year they make a slight improvement, but if you look at it over 10, 20, or 30 years, they've made giant improvements.
Sure.
And so that's going on. Obviously breeding for improved stress tolerance is a big thing. Heat stress and drought, in cool season grasses now, heat stress and drought stress are big points of emphasis.
Absolutely.
And water use. And so it's great to see what they're doing, the breeders are doing. They're making great progress.
That's great. Real quickly, I know one thing you talked about was product efficacy. This is just to help make sure that the products are doing what they're supposed to be doing, and this is a continual that's used to help basically continue to further it with the market. Is that correct?
Right. Yeah, product efficacy, a big part of university research programs, a big part of industry research programs, and you nailed that. That's exactly what doing is what products, how effective they are on a particular problem, and how can superintendents use them in the best fashion to get the best results.
Fantastic. Hey, we're running out of time, Clark. I appreciate you taking the time to kind of share what's going on in the industry. Again, this is going to wrap up this segment of GCSAA TV, which is presented in partnership with Lebanon Turf. Coming up next is we got a video about what's in your bag, and we're going to be going to TPC Boston. We look forward to seeing you for the next segment, where we're going to talk about the use of social media in our industry. I appreciate it. Clark, thank you.
Thanks, Chris. Enjoyed it very much.
Indeed.